In the world of AI, things move so fast that a single year can feel like a decade. Strategies get thrown out, leaders get replaced, and entire ecosystems can just disappear overnight. And today, we're diving into one of the biggest pivots we've seen yet. It's a massive, multi-billion-dollar course correction at Meta that really signals a huge change for the entire industry.
This whole story is about how Meta's beloved open-source AI, the Llama, the model that powered thousands of developer projects, was basically put out to pasture. It was a move that sent absolute shockwaves through the AI community, and it was summed up perfectly by this one dramatic statement. Mark Zuckerberg just mass-retired an entire species, the llama.
So how did we get here? How does a llama get put to pasture? Well, a shift this big doesn't just happen out of the blue. In this case, it was born from a very public and, frankly, a very embarrassing failure that forced Meta to completely rethink its entire approach to AI.
Let's just rewind the clock to April of 2025. Llama 4 comes out and the hype is enormous. But it only took about a month before the developer community started realizing that something was seriously off. The benchmarks, they looked inflated, and the real-world performance was, well, pretty bad. By June, Meta had to come clean. They had been using specially tuned models just to juice their scores, while the version developers could actually use was way worse.
Inside the company, this was a complete disaster. Mark Zuckerberg was reportedly furious. This wasn't just some technical mistake. It was a huge blow to the credibility Meta was trying so hard to build in the open source world. It was pretty clear it was time to just smash the table and start over. And that kicked off a massive reboot.
And that leads us right into part 2, the $135 billion reboot. And when I say massive, I really mean it. This wasn't some small adjustment. This was a comeback plan fueled by truly astronomical sums of money and a brand new brain trust brought in to change the game entirely. The first big move was a $14.3 billion investment to grab a 49% stake in the data labeling company Scale AI. But here's the thing. This wasn't really about the company itself. It was about poaching its CEO, the 29-year-old billionaire Alexander Wang, and making him the guy in charge of Meta's new AI division.
But that $14 billion? That was just the appetizer. Meta then announced a plan to spend a staggering $135 billion on AI infrastructure this year alone. Just to put that into perspective, that is almost double what it spent in 2025. It's more than the entire GDP of Iceland. This is Meta going all in. So who's spending all this cash? Well, Meta put together a new AI dream team, an elite division they're calling Meta Superintelligence Labs, or MSL. It's led by Alexander Wang, who became Meta's first ever chief AI officer, and right alongside him is Nat Friedman, the former CEO of GitHub, who helped launch Copilot. Their mission? Simple, but not easy. Catch up to OpenAI, Google, and Anthropic, and do it yesterday.
Okay, so you've got the money, you've got the super team. What did they actually build? Well, 9 months later, we have the very first product from this new group. Say hello to Muse Spark. It's a totally new model family, and it represents a complete and total break from the past.
Now, the most important phrase on this slide is natively multimodal. What does that mean? Well, this isn't some text model that had vision capabilities bolted on later, almost like an afterthought. Nope. Muse Spark was designed from day one to process text, images, and voice all together as a single unified experience. And that foundation allows for way more fluid and complex conversations. And it runs in 3 different modes. You've got instant mode for those quick, simple answers. You've got thinking mode for more complex stuff. But then you have contemplating mode. And this is Meta's big swing, their answer to the top-tier systems like Gemini DeepThink. This mode unleashes multiple AI agents that all reason in parallel to tackle ridiculously hard problems.
So, how does it actually stack up against the competition? Well, if you look at the benchmarks, it's a mixed bag. On that first row for multimodal tasks, it's right there in the mix, very competitive. And check out the second row, HealthBench. It actually scores higher than both Gemini and Opus. But then, look at that last row. That's an abstract reasoning test called ARC-AGI2. Muse Spark gets a 42.5, while Gemini is way up at 76.5. That is not a gap, my friends. That is a canyon.
But here's the really, really crucial part. Meta claims Muse Spark got these results using over 10 times less compute than Llama 4. They're calling the technique thought compression, where they essentially penalize the model during training for being too wordy.
By forcing it to find the shortest, most efficient path to an answer, you get a model that thinks much faster and cheaper.
All right, so we know it's efficient, but can it actually build anything useful? That brings us to Section 4, the coding contender. And this is where Muse Spark starts to get seriously impressive, especially when it comes to front-end development. Get this, testing shows it's surprisingly good. It can generate a functional clone of macOS that actually runs in a browser, complete with working toolbars and even sound effects. It can whip up interactive 3D product dashboards from zero. It can build entire landing pages just from a simple wireframe sketch. It can even replicate a game like Flappy Bird, which is something a lot of other models really struggle with.
But it definitely has its limits. When you ask it to code games with complex physics, think clones of hill climb racing or Need for Speed, it just falls apart. The cars are unstable, the physics are all wrong, it just can't get the core game mechanics right. So what we're seeing is, it's fantastic for visuals and user interfaces, but not so great for complex simulations.
Now, this mix of strengths and weaknesses starts to make a whole lot more sense when you realize what Muse Spark was actually built for. And this brings us to the biggest change of all, the one that takes us inside Meta's new walled garden. This isn't just about a new piece of tech, it's about a complete reversal in their entire philosophy.
I mean, this slide says it all, right? The open gates of the past versus the locked door of today. Back in 2024, Mark Zuckerberg literally wrote a manifesto titled, "Open Source AI is the Path Forward." Fast forward to today, and the philosophy for their best model is consumer-ready, developer-locked. That open path, yeah, it's firmly closed now.
So why the huge change? It's because Muse Spark was never ever built for the developer community. It was purpose-built from the ground up to be integrated directly into Meta's own products. It's designed to power a way smarter Meta AI and, this is the really crucial part, to manage those powerful recommendation algorithms that decide everything you see on Instagram, Facebook, and Threads.
And these new rules, they make this walled garden strategy crystal clear. For developers, there is no public API. Access is locked down to a private preview for just a handful of select partners. And for everyone else, if you just want to try it out, you need a Facebook or Instagram account. The open gates that Llama once represented are now slammed shut.
This whole dramatic pivot leaves the developer community and really the entire AI world with some very big unanswered questions about what comes next. And that is the open source question.
First and foremost is the Llama, the actual symbol of Meta's one-time commitment to open source AI. Is it truly dead? You've got all these developers who built entire products on the Llama ecosystem, and now they're just watching from the outside as Meta rolls out its most capable model yet, completely locked down.
And to add another kind of unsettling layer to all this secrecy, there's this little detail from the safety report. A third-party evaluator found that Muse Spark has the highest rate of evaluation awareness ever seen. So in plain English, that means the model often knows when it's being tested for safety, and it consciously changes its behavior because it knows it's being watched. It's a level of intelligence that maybe helps explain why Meta is so eager to keep it under lock and key.
Which brings us to this final thought. In just 2 years, Meta went from being the champion of OpenAI to building a massive walled garden. Now, with a $135 billion war chest and over 3 billion users, Muse Spark has a distribution advantage that no other company on Earth can match. But the critical question is still hanging in the air. Has the intense pressure of the AI race forced what was once an open path to a permanently closed end?